I am extremely happy to welcome the viewers of my channel for 10th module in Success to Gate on Control Systems. Like the previous module, in this module also, I have covered the problems pertaining to route array in the gate examination question papers. So I have considered the gate exam question papers of chemical engineering, electronics and communication engineering, and instrumentation engineering. I'll straight away move to the problem. Problem number 1, it is taken from 2017 Electronics Engineering Set 1, question number 5. Consider the following statements for continuous time linear time invariant systems. Number 1, there is no bounded input, bounded output stable system. That is BIBO stable system with a pole in the right half of the complex plane. Second option, there is no causal and BIBO stable system with a pole in right half of the complex plane. Which one among the following is correct? Both the statements are correct because we cannot have a stable system with a pole in right half of its plane. Similarly, causal and BIBO stable system, they are also stable, comes into picture. So we cannot have a stable system with a pole in right half of its plane. Since that BIBO stable system is there in both the statements, both are correct only. So both 1 and 2 are true. Therefore, option A is correct. So let us move on to the next problem. So second problem is taken from again GATE 2017 Electronics Engineering Set 1. Question number 48. Which one of the following options currently describes the locations of the roots of the equation s power 4 plus s square plus 1 equal to 0 on the complex plane? So four options are given. So we should check whether how the roots are in the left half plane or right half plane or imaginary axis. So definitely this problem we have to do with route array only. So how can we do it with the route array? Very simple. So formulate the route array. There are two coefficients which are missing, that is s coefficient and s cube coefficient. Otherwise we can do the problem as usual. So s power 4 s square 1 is the first row. Next row is s cube row and s row. S cube and s term are missing, so 0. That means row of zeros. So whenever we get row of zeros, we have to replace that row of zeros with the derivative of the auxiliary polynomial formed with the previous row to the row of zeros. So that is s power 4 plus s square plus 1. That is the given equation itself. So dA by ds is 4s cube plus 2s. So replace this row of zeros with that 4 and 2. So formulate the remaining elements of the route array as usual. This into this minus this into this divided by this. Same way, if we find, we can see that positive, 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 negative, positive. So two sign changes in the first column of the route array. Two sign changes means two roots will be in the right half of this plane. So two RHP roots among the four options, only it is falling in option C. Definitely option C has to be correct. Anyway, to confirm it, anyway we have tried to solve the characteristic polynomial, because characteristic polynomial solution will definitely yield complex roots. However, here x square plus x plus 1 will not yield imaginary roots. It will have real as well as imaginary. That means the real part will have left, will be located in the, the roots will be located in the left of west plane, those two roots, or the real part of those two roots will have negative sign. That's all. That is the meaning. Therefore, two roots in the right half of this plane, two roots in the left half of this plane. So, if you want, you can solve this, but no need. Therefore, this particular solution falls into option C. So, option C is correct. So, let us move to the next problem. So, it is taken from 2017 Chemical Engineering, question number 52. So, the characteristic equation they have given. What is the value of K beyond which the system becomes just unstable? That they are asking. So as usual, form the route array 6 first row, next row 11 1 plus k, so 11 into 6 minus 6 into 1 plus k divided by 11. All that if you do, first column elements have to be positive for system to be stable. That is possible only when this k is anyway, k greater than minus 1. That is not a problem here, but this only is the thing. So 60 minus 6k means 6k should be less than 60 or k should be less than 10. So when k is greater than 10, even though this is positive, this will be negative. Therefore, it will be unstable. Therefore, what is the value of k beyond which the system is unstable is k equal to 10. So let us move on to the next problem, problem number 4. So it is taken from 2016 instrumentation engineering, question number 13. So what is the value of a naught that will ensure that the polynomial s cube plus 3s square plus 2s plus a naught has roots on left half of s plane is, they are given. So formulate the router A. So first row 1 2, next row 3 a naught as usual. So 3 into 2 minus a naught by 3, all that we have to do. So when the system will be stable, only when the system is stable, it will have roots in the left half of S plane. So that is possible only when the first column elements are positive. That is possible only when a naught greater than 0 and a naught less than 6. Otherwise, when a naught is greater than 6, greater than or equal to 6, this will be negative. Therefore, a naught should be less than 6. A naught less than 6 means what is the option which is less than 6? 5. Therefore, option D. So, option D is correct. That's all. See how simple it is. So, last problem in this module. So, it is again taken from instrumentation engineering, question number 39. The transfer function they have given, we should find out the system cannot be stabilized with which of these options. That is, when you add what particular transfer function here, system will be unstable. That means this is like a controller transfer function. These two are forward part transfer function. That's all. These two have to be multiplied into g of s plus 1 plus g of s h of s equal to 0. That's all. So all these four are fitting into same form a plus b by c. A plus b by c. Here again a plus b by not b by c, a plus b by s, a plus b by s, a plus b by s. Of course here a is 0, b by s. So g of s is 1 by s plus 1 whole square multiplied by this c of s. So 1 plus g of s, c of s. H of s is 1. So 1 plus 1 by s plus 1 whole square into a plus b by s equal to 0. So if you solve this, s cube plus 2s square plus 1 plus as plus b equal to 0. Therefore, for this we have to formulate router A. So s cube row is 1 a plus 1, 1 plus a, that is a plus 1. S square row is 2b. Therefore, 2 into a plus 1 minus b divided by 2. So that is 2a plus 2 minus b by 2. This is b. So for the system to be stable, all the first column elements have to be positive. So if not, it will be unstable. That we have to find out what option will make it unstable. So b greater than 0, anyway all the cases b greater than 0 only, 3, 9, 7, 1. Therefore here we should check the value of a, compare, we have to compare. So 2a plus 2 minus b by 2. So first option a is 1, b is 3. So 2 into 1, 2 plus 2, 4. 4 minus 3, 1. 1 by 2 is definitely greater than 0. So it will be stable only. It cannot unstabilize the system. Second option A3, B7. So 2 into 2, 4. 4 plus 2, 6. Sorry, 2 into 3, 6. 6 plus 2, 8. 8 minus 7, 1 by 2. This also will not destabilize. Third option A3, B9. So 2 into 3, 6. 6 plus 2, 8. 8. This is 9. B is 9. So 8 minus 9 by 2. Definitely it will make negative. Therefore, it will unstabilize the system. Anyway, we'll check option D also. Option D, A is 0 because that constant term is not there. So 0 plus 2, B is 1. So 2 minus 1 by 2, half greater than 0. So only option C makes this less than 0. Therefore, that will be negative. Therefore, system will be unstable. Therefore, system cannot be stabilized with option C. So option C is correct. So if you go through all these modules pertaining to route stability also, that is Module 8, Module 9, Module 10. No new formula, no new expression was used for solving any of the gate problems. Only the standard simple approach was used for solving all the problems. Anyway, throughout my gate series, that is from Module 1 to Module 10, I have been using only standard and simple approach for facilitating the learners to grasp things in the same sequence so that they will not have to remember big formulas. That is one thing. Second thing, their confidence has to be boosted. Third, they have to score very good marks in gate examination, whether they belong to electrical or electronics or chemical or instrumentation. They should crack 100% in control system questions. I have already said control system questions, some 10 to 15% they ask. Therefore, 10 to 15% if one can score without any difficulty, he or she can score very good marks in the GATE examination and secure all India rank. So if you have any doubts in any of this, you can also refer my control systems lecture series lecture 9, where I have done this router visibility criterion in detail. That URL is also given. And if you have still doubts, or if you want to post any comments, or if you want to post any questions, or if you want to give me feedback, so I'll be happy to receive it. So please post it in c.ganesh.srt@gmail.com or this number 9994347426. This number you can WhatsApp. So I thank you very much for the support that you have been giving in terms of views, shares and subscriptions. So I expect you still better support for me by viewing videos for longer time and sharing my videos and subscribing the channel. Once again, I thank you. I will meet you in the next module, that is module 11. There again, I will do with the route array problems.